Okay. So last meeting class, we ended our discussion about molarity, right? Our topic is about solutions, and including in the concept of solutions is the concentration. So the first unit of concentration that we discussed is the molarity. So do not forget, when you say molarity, we are computing the number of moles of solute that is being dissolved in a liter of solution. So always remember, if the problem gives you an amount of sample in grams, you have to convert it first to moles. Using our formula, moles is equal to the weight of the substance in grams divided by its molar mass, or its molecular weight. Now, if you have converted grams into moles, you have to ensure also that the volume of solution is in liters. So if ever you will be given a volume in milliliters or other units, you have to really convert it to liters before proceeding with the computation of molarity. And then do not forget, our unit for molarity is either capital letter M or moles per liter. So yung capital letter M, we read that as molar. Okay, that is molar class. We are done with the computation except for the assignment, and we'll have that later if I still have time. Now, the second unit of concentration is called molality. Okay, do not be confused because it's almost similar. The other one is molarity. Molarity. Ako na din ang na-confuse. Molarity, and then this one is molality. Okay, now what's their difference? For molality class, we are still computing the number of moles of solute, but this time it's over mass of solvent in kilograms. So that's their difference. Instead of liter of solution for molarity, molality is mass of the solvent in kilogram. Therefore, the unit of molality is moles per kilogram, not moles per liter, moles per kilogram, or capital letter M. Now, if you are going to write the unit for molality, you have to make it clear whether you are writing capital letter M or small letter m. Para hindi tayo ma-confuse, hindi din ako ma-confuse when I will be checking your submissions. Kasi pag meron kasing nagsusulat ng capital letter M and small letter m na almost similar. So pakiklaro, kasi they are two different units of concentration. So let us have an example. Sample problem about molality. We have here number 1, calculate the molality of 25 grams of potassium bromide dissolved in 750 ml pure water. Wait lang, let me write on the screen. Do not forget our formula, molality, small letter m, is equal to moles of our solute divided by kilograms of our solvent. This is for the solvent ha, kasi si molarity liters of solution. Ito kilograms of solvent lang. Now, in our problem, the given, we have 25.0 grams. This is for our solute, the potassium bromide. And this is dissolved in 750 ml pure water. So number 1, we have to convert this first into moles. We will be using this same formula in converting grams to moles. Moles is equal to the weight of the substance or the sample in grams divided by its molar mass. Now, the given is 25.0 grams. However, we need to look for the molar mass of potassium bromide first. So this is KBR. The same way of computing, you just have to identify how many atoms of each element are present. For potassium, we have 1, and so does with our bromide. And then kindly take out your periodic table for the atomic masses or atomic weights of these elements. We need to round them off to the nearest whole number. Kindly check potassium
39, ma'am.
39, ma'am.
Thank you. That's 39. How about the bromine?
80 po.
80, ma'am.
So this is 80. And then let's add this 39 plus 80 is 119 grams per mole. Okay, do not forget the unit, it's grams per mole. This is 119 grams per mole. Let's divide this. Let's cancel the grams. So 25 divided by 119, medyo mahaba. Let's not round off when we are doing the process. Let's round off during the final answer. So 0.210084.033 moles. Ito yung gagamitin natin in the computation. Again, 0.210084.033 mole. Now take note, kilograms of solvent. Our solvent here is pure water. And ano ang nakalagay? 750 ml. So, ganito class, pag pure water, this is only applicable for pure water. 1 ml of pure water is equivalent to 1 gram. Okay? Ang weight ng isang ml ng tubig is 1 gram. So definitely, if you have 750 ml here, this is equivalent to 750 grams. Okay? Do not forget that this is only applicable for pure water. Now, this 750 grams, i-convert natin into kilograms. Okay? So this is kilograms here. Grams ang sa baba para makancel natin. Now, ang isang kilogram is equivalent to 1,000 grams. So makancel natin ito. 750 divided by 1,000 is 0.75 kilograms. So we have completed now the things required to compute for molality. So, pwede na tayong mag-divide 0.210084.033 moles divided by 0.75. 2 decimal places lang. This is 0.28. Take note of the unit. It can be moles per kilogram, or you can simply write 0.28 and then small letter m. So this is now the concentration in molality of our potassium bromide solution. So again, the computation is almost similar to that of the molarity, except that you have to get the weight in kilograms of the solvent. If it is pure water, 1 ml is equal to 1 gram. And then you just have to convert grams to kilograms using the conversion factor. 1 kilogram is equal to 1,000 grams. Okay, questions for this problem? Or do you want to clarify something about the process of computing molality? Should be able to distinguish this. If we are going to have our face-to-face class or laboratory activity, you have to check the label of each chemical kung anong unit yung ginamit. Pag capital letter M, molarity yon. Pero kapag small letter m, it's molality. Both of them, again, are units of concentration for our solution. Can I erase the writings on the screen now and proceed? Wala pa? Okay. Sige. Let's wait for the others to finish working. Okay na? Okay. Sige, let us have another example. We have this one. And please try to compute first in any sheet of paper there, and then we'll answer after the screen. Sige, second problem, calculate the molality of 2.0 grams of calcium oxide dissolved in 1050 ml pure water. Okay, you try, you follow my example a while ago and compute for the molality. Okay, sige, let's wait for the others. Finish computing this. Okay, sige. Let us check whether the answers you sent in the chat box are correct. Some of you answered 0.03, others 0.02. Now let's check. Again, molality is equal to moles of our solute divided by kilograms of our solvent. But these two are not really given in the problem, so we have to compute for them first. So this 2.0 grams will be converted into moles. Our formula, moles is equal to weight of our sample divided by the molar mass. So now the weight of our sample is 2.0 grams. The molar mass should be computed also. Calcium and oxygen, 1 atom each. So this is 40, right? So this is equal to 40 and this is 16. So this is a total of 56 grams per mole. Ito yung gagamitin natin, 56 grams per mole. Let's cancel the grams. 2.0 divided by 56 is 0.035714285 moles. Okay, so yan yung gagamitin natin here, 0.035714285 mole divided by kilograms of our solvent. Our solvent is pure water, and I told you a while ago, 1 ml of pure water is equivalent to 1 gram. Therefore, if you have 1050.0 ml, this is also equivalent to 1050.0 grams. We just have to convert this into kilograms. So 1 kilogram is equivalent to 1,000 grams. So 1,050 divided by 1,000 is 1.05 kilograms. Yan yung ilalagay natin here. Now, let's proceed. 0.035714285 divided by 1.05. 2 decimal places, 0.03 moles per kilogram. Wait lang. Ayan, moles per kilogram or 0.03 small letter m. So this is now the concentration of the prepared calcium oxide solution. It's 0.03 molal. We call that molal ha. Pag capital letter M, molar. And then ito 0.03 molal. That's the concentration of the 2.0 grams calcium oxide dissolved in 1050 ml of pure water. So yes, you got the correct answer. Yung mga nag-answer ng 0.02, maybe nag-round off kayo during the process, kaya naging 0.02. Please bear in mind that we will be doing the rounding off sa final answer na. So pakikopya na lang. Please be patient with the with those numbers na daghan kaayo. Now, let's have this one. Calculate the amount in grams of zinc chloride in 1,300 ml of 2.3 molal zinc chloride solution. The specific gravity for the zinc chloride solution is 2.9. So this one is a different problem. It's more complicated than the previous ones that we have. Baliktad ito. Yung given natin here, lista natin yung given. The given is, given yung molality, that's 2.3 molal. And then, given din yung volume ng solvent, that's 1,300 ml. And then, given yung specific gravity ng ating zinc chloride, which is 2.9, we don't have unit though for the specific gravity. And what is asked in the problem is the amount in grams. So this is the weight of the sample. So pabaliktad itong problem na ito, class. Okay? So what are we going to do? If you are confused on what to do first, you go back to our main formula. Our main formula, remember, is molality is equal to moles of our solute divided by kilograms of our solvent. Now, mamaya na tayo mag-derive ng formula. Ilagay na lang muna natin kung ano yung given. Remember that the molality is given. So we can write 2.3 m here. But para mas madali yung pag-convert ng unit, let's just use the moles per kilogram. Kasi hindi natin makikita yung cancellation of the unit if we use the small letter m. Now, the moles is not given in the problem and we cannot compute for it since remember grams ang hinahanap. So yan yung magiging question mark first. Now, the kilogram of our solvent. Now, take note, this is zinc chloride and given yung volume 1,300 ml. Pero yung binigay ko kanina na 1 gram is equal to 1 ml is not applicable here. Kasi hindi naman sinabi na ang solvent mo ay pure water. Okay? So, dyan papasok si specific gravity class. Okay? Remember, in computing for the specific gravity, this is the density of the substance divided by density of the reference standard, and mostly this is water. This is how we compute for the specific gravity. Now, the specific gravity of zinc chloride is 2.9. That is given in the problem. We will be looking for the density of the zinc chloride. So, this is for the substance. Now, class, yung density ng water, automatic yan siya. 1 gram per ml. You just have to be familiar with that the density of water is 1 gram per ml. Now, we can compute for the density of our zinc chloride or our substance. Let's just do cross multiplication here. We will be writing density of the substance here, and then 2.9 times, magiging 2.9 times 1 gram per ml ito. So definitely this is 2.9 grams per ml. Okay? Density pa lang ito ng substance natin, how we are not yet done. So actually, nilagyan lang talaga natin ng unit yung 2.9. Now, saan natin gagamitin yung density of the substance na yan? Remember, class, in computing for the density, our formula is mass over volume. Okay? Medyo na-complicate na, no? Pero sundan nyo lang, please, yung ating ginagawa here. Now, the density that we have computed is 2.9 grams per ml. And then, wait lang. Asa na tayo? Grams per ml, mass over over volume. Baliktad ata ang ginawa ko. This is mass here. So we will be looking for the mass. Baliktad pala ito. Excuse me. The 2.9. Okay. And then this is mass over volume. Tama. In-erase. We will be looking. Okay, the volume for the zinc chloride is 1,300 ml. So yan yung binigay here. We are looking for the mass para may ilagay tayo here in kilograms. Now, ganun pa rin, cross-multiply, ibaba natin si mass, 2.9 grams per ml times 1,300 ml. And then, let's cancel the ml since nasa baba yung isa, nasa taas yung isa. 2.9 times 1,300 ml is 3,770 grams. Yan yung amount in grams of the zinc chloride solution. Anong gagawin natin here sa mass na na-compute? Ito yung i-convert natin into kilograms. Okay? So 1 kilogram is equal to 1,000 grams. Cancel natin. 3,770 divided by 1,000 is 3.77 kilograms. Ulitin ko yan siya. Explain later ha. Ipatuloy muna natin. Medyo mahaba ito na computation. Okay? So meron na tayong amount of the solvent in kilograms. Kasi hindi siya given sa problem. Ang given, 1,300 ml. Okay? Pero since hindi yan siya pure water, kaya natin ginamit si specific gravity and density. So cross-multiply ulit tayo dito. Ibaba natin si moles. This will become 2.3 mole per kilogram. Mole per kilogram times 3.77 kilograms. We will cancel the kilograms. And then 3.77 times 2.33 is 8.7841 moles. Moles na lang yung naiwan na na unit. Okay? Pero we are not yet done. Bakit? Kasi ang hinahanap grams. Let's be patient with this problem since it's very long. Delete ko lang yung given kasi I don't have space anymore. Balikan natin yung ating formula na moles is equal to the weight of the substance or the sample divided by its molar mass. Remember that na-compute natin si moles, 8.7841 moles is equal to, ito yung hinahanap natin, weight of the sample. And then, for the molar mass, our sample is zinc chloride. Class, si zinc chloride, ang formula niyan, zinc, and then, remember, zinc is a transition metal. This is +2, chloride is -1. We have to do the crisscross. The correct chemical formula for zinc chloride is ZnCl2. So, i-compute natin yung kanyang molar mass, isang zinc, dalawang chlorine. Kindly check what is the atomic weight of zinc?
65, ma'am.
65. Okay, so this is 65. Chlorine is 35. So 35 times 2 is 70. Let's add this. 70 plus 65 is 135 grams per mole. So yan yung gagamitin natin here. 135 grams per mole. And then the same thing, let's do cross multiplication. Weight of our sample is equal to 8.7841 mole times 135 grams per mole. You have to cancel this. Ayan. And then 135 times 8.7841 is 1,185.85 grams. So yan ngayon, yung amount in grams of zinc chloride that is to be dissolved in 1,300 ml para makuha mo yung 2.3 molal na solution. So again, medyo mahaba lang yung computation ng problem na ito. Balikan natin yung ating process. Anong hinahanap sa problem? Amount in grams of our substance. Meaning, yung weight ng ating zinc chloride na gagamitin para magawa itong 1,300 ml na solution. Pero dapat ang kanyang concentration is 2.3 molal. Now, you have here the specific gravity of the zinc chloride solution, it's 2.9. So ano ang una nating ginawa? Kinonvert muna natin, kinuha muna natin yung density of the substance dito. Do not forget the formula, density of the substance divided by density of water. Given yung specific gravity ng substance natin, yung density ng water, constant yan siya, automatic 1 gram per ml. Okay? So, i-substitute nyo lang siya sa ating formula. Magko-cross multiply tayo. So, density of the substance is equal to 2.9 times 1 gram per ml. So, nakuha natin yung density. This is for the zinc chloride. Bakit natin kukunin si density of the substance? Kasi kailangan natin i-convert class si 1,300 ml into kilograms. And hindi siya automatic kasi hindi nakalagay dyan na it's pure water. So again, kailangan natin si density. So ito yung formula ng ating density. Density is equal to mass over volume. Now, yung computed density of our zinc chloride is 2.9. And then according sa problem, yung volume niya is 1,300 ml. So kakailanganin natin makuha yung mass. So ganun pa rin, substitute. Ito, this is for density and then the volume is 1,300 ml. And then cross multiply again. For us to get the mass of the solution, multiply lang 2.9 grams per ml times 1,300 ml. Cancel the ml plus. Yung mass ng ating solution is 3,770 grams. Pero sa problem, kailangan mo siyang i-convert into kilograms. So, ganun pa rin. 3,770 grams times 1 kilogram over 1,000 grams, that's 3.77. So, pag meron na tayong mass, pwede na tayong mag-compute ng moles. Balikan natin yung original formula natin here. Okay? So, pag na-compute natin yung moles, meron na tayong moles dito, pwede na nating makuha itong weight of the sample. Kailangan lang natin i-compute yung molar mass ng ating substance, which is zinc chloride. Pero the process is still the same, cross multiplication, baba mo itong weight of sample, and then i-multiply mo yung moles, and then yung computed natin na molar mass. So ito yung ating sagot, 1,185.85 grams. Medyo mahaba yung ating problem. Okay, questions? Should I give you, what's the time? Oh, it's already time. I'll give you na lang an assignment and then we will be answering the assignment tomorrow. So this same na problem, wait lang ha, isulat ko siya sa screen. It's so long. You really need to be patient here kasi medyo mahaba. Okay? So I'll be writing your assignment on the screen. And then yung assignment kahapon, sabay natin sagot tomorrow. Any sheet of paper ito ha. Ay. SPGR. SPGR of sodium hydroxide. Wait lang ha. Hindi ko ito memorize. Let's ask Google. What's the specific gravity of NaOH? 1.52. Okay. Sige, yan lang. Isa lang. And then, try to follow the solution na binigay ko. Mabubuan lang. Wala man tayo mabuhat. Wala tayo mabuhatan. Ikaw ingan, i-judge siya ang problem. Kasi sa laboratory class, you will be asked to make your own solution with the given unit or given concentration. So kung hatagan mo na, dapat ang inyong buhaton 0.25 molal na sodium hydroxide and dapat ang volume niya 2,500 ml, you should know gaano karaming sodium hydroxide in grams ang gagamitin ninyo para mabuo nyo yung solution. So magko-compute tayo sa lab. Okay, so please copy your assignment, any sheet of paper, 2 decimal places, show your solution. Now I'll just provide a submission bin later sa Schoology. Okay?